Hey guys, welcome to Unit 2, Section 2. Today we're going to talk about solving inequalities using the addition and subtraction property of inequality. All right. Essentially, the key concept here is just like solving equations, we're going to solve inequalities using the inverse operation to isolate the variable. Now, when we add the same number to both sides of an inequality, it creates this equivalent inequality. And likewise, when we use the subtraction property to subtract the same number from both sides of an inequality, it will create an equivalent inequality. And equivalent inequalities simply have the same solution set, just like equivalent equations have the same solution. All right, we're going to jump right into some examples for today. So solve the inequalities below and graph the solutions for those that include a number line. All right, so here we have some number plus 5 more is less than or equal to -8. Simply going to subtract 5 from both sides, right, using that inverse operation of addition to move that 5 across the inequality. And that leaves us with x is less than or equal to -13. And when we go ahead and graph that solution set, we're going to number our number line. We'll start off with -15, -14, -13. All the way up to here, let's just go to -10. Now, it's an inequality that's less than or equal to, so the less than or equal to gets a closed circle at -13, so you're going to fill that circle in, and less than or equal to is everything that is to the left of -13 on that number line. So any number like -15, -20, -411 would be a solution to that inequality. Example 2, we have another inequality here with a little bit of a fraction. We got -31/3 plus x is greater than 8/3. So we're going to add 31/3 to both sides of that equal sign, or sorry, that inequality sign, in order to remove that and isolate the variable x. So now we have x is greater than 8/3 plus 31/3. Since they already have the common denominator, we're going to add the numerators, and that gives us 39/3. Now we should always reduce our fractions as best we can here. That means x is greater than 13. All right, we're going to graph our solution set here. We'll start off with 10, 11, 12, 13, 14, 15, 16, 17. Again, you want to list some numbers on your number line to the left and to the right of that number that you're looking to start with. Since we want all the values that are greater than 13 but not including 13, we're going to start with an open circle and an arrow pointing to the right, indicating values that are greater than 13. So any number greater than 13, such as 16 or 20 or 411, would be a solution to this inequality. All right, in example 3, we have 4.8 is greater than or equal to x plus 9.2. We're going to subtract over our 9.2 in order to isolate our variable. 4.8 minus 9.2 results in -4.4. Is greater than or equal to x. Now this is a little bit of a different inequality than the ones that we've seen before. The first two final solutions had x listed to the left of that inequality. Here we have x that is listed to the right of it. If I want to rewrite this so that x was on the left, then I want to make sure my inequality points towards my x. So I'll have all x's less than or equal to -4.4. All right, so once again, we're going to label -4.4 right here in the middle of our number line. And moving to the right, we got -3.4, -2.4. To the left, we got -5.4 and -6.4. This is just one way to number your number line. And since we're going to take a look at this one right here, we want all x values less than or equal to -4.4. We're going to start with a closed circle because -4.4 is a solution, and we're going to draw our arrow to the left and color that arrow in. There is the graph of our solution set. All right, let's try a word problem or two. We have the weight limit for an elevator is 1,000 pounds. If 6 people are on the elevator and they weigh a total of 772 pounds, how much weight that can be added to the elevator without going over its limit. All right, so let's identify our variable. X here is the weight that can be added to that elevator. And we're going to set up our inequality here as x, the weight that can be added, plus the already 772 pounds that we have, has to be, it cannot go over, right? The weight limit implying that it can be equal to 1,000, but can't be greater than it. That means it has to be less than or equal to 1,000 pounds. All right, so solving our inequality, we'll subtract our 772 from both sides, and that gives us x is less than or equal to 228 pounds. Now let's graph the solution to that. So we're going to create our own number line here, and we're going to label our 228 here in the middle, 230, 232, so on and so forth. All right. Oops, that's 224. Our arrows that go off in both directions. All right, so we're going to shade our circle here. It's going to be a closed circle indicating that we can have 228 pounds and anything less than that. So there is the graph of that solution set. All right, finally, example 5 says write and solve the inequality. The difference between a number, that's our variable, and 7 is no more than 19. All right, so a couple of key English words here. Difference means subtraction, so we're going to subtract between a number, that's a variable. Let's just call that y, and 7. All right, so we're going to say y minus 7, there's the difference between a number and 7, is no more than. All right, the is no more than, if you remember from our phrases, is the less than or equal to 19. All right, in order to solve, we're going to add our 7 over, and we get all y values that are less than or equal to 26. Go ahead and graph that solution set on your own number line, and we'll check your work tomorrow.